Good evening, everyone. We have clean drinking water on our table. We may soon require oxygen cylinders, and we are very dangerously close to that. And it's always better to monitor the ambience or the quality of air around us. And this is about a decentralized way or micro environment monitoring way of knowing the ambience of the air or the quality of the air with one air quality monitoring station. My name is Mohan. I work in CDAC, Bangalore. CDAC is a scientific society of Ministry of Electronics and Information Technology, Government of India. And this air quality monitoring station is one of our deliverables in our Smart City project. We also have water distribution network, smart water distribution network, and home energy automation, early fire detection and safe guidance exit system, and some other deliverables. And if you see the national ambient air quality standards, as per Central Pollution Board of India, these are the pollutants that are mentioned, majorly sulfur dioxide, nitrogen dioxide, ozone, carbon monoxide, ammonia, lead, and dust particles PM2.5, PM10, and other benzene, benzo, pyrene, arsenic, and nickel. And if you see the satisfactory levels, they are given in 80 or 100 micrograms, and they are measured for every 24 hours. And at least 98% of the time, they should be within this limits. If it is within that limits, then they are safe. And these are the, out of the pollutants that was mentioned earlier, these are the pollutants that we are targeting. Sulfur dioxide, nitrogen dioxide, ammonia, carbon monoxide, ozone, and of course, I missed PM2.5 and PM10 dust particles. And these are the ranges mentioned. This is converted in ppm, parts per million. If you see nitrogen dioxide, good ranges like 21 or ppb, parts per billion, or 0.021 parts per million. And these are very stringent requirements. If you see the commercially available sensors, it might say it can detect from 0 to 10 ppm, but what we want is with less than 0.5 ppm even, which if we use those sensors, we may lose the resolution. So it's, we have to carefully choose the sensors type of, or principle of sensing involved in this. And this is our air quality station where we have a set of sensors with a setup of where we sample the air in. And the moment you talk about sensors, the problem is the sensitivity. The sensitivity varies over time. There is a drift and there is a cross sensitivity. So to find out the sensitivity, you need the calibration. You need to calibrate the sensors. So we have a mechanism to auto-calibrate. It's generally recommended to calibrate once in 3 months, but with this technique, we calibrate once in a week to correct the sensitivity and the drift factors. And if you take one sensor nitrogen dioxide, it does not sense just nitrogen dioxide, it also senses other pollutants. So there is always a cross sensitivity associated with that. And we have a novel technique to eliminate this cross sensitivity. And we are filing a patent on it. And along with that, we have a controller and a communication interfaces with GSM modem mounted on a pole. This is a pole mountable sensor which monitors all these parameters for different zones, industrial zone, commercial, residential, silent zones. We are discussing with the Karnataka Pollution Board and coming up with analytics required for these different zones. And this is, if you see, this is the typical dashboard of BTM layout, where there's one pollution monitoring station deployed by Pollution Board of India. At least some 6 pollution stations are there in Bangalore, which just gives a crude information of the pollution levels present in Bangalore. If you have decentralized monitoring stations, micro monitoring stations, then we'll get a better understanding of the available air quality. And this is a dashboard that we are working on. We have shown just few sensors which can be configured. This is our office where we have deployed a node. And there are few sensors, we have not considered all the sensors here. Nitrogen dioxide, PM2.5, PM10, and carbon dioxide. Of course, carbon dioxide is not just an indoor quality, but anyway, we have considered for both indoor and outdoor. And If you see, this is the dashboard view available for the local urban bodies. Once they install the units, they can configure the sensors associated with that. Once they configure the sensors to that particular node, they can give a node name and location of that station. By that, they'll come to know what are the stations, which station is giving the signals from it. And the typical the site engineer can view a node of a particular location. Here it is mentioned a CDAC office, when he can monitor all the parameters that are available in that area. All right, and there are some thresholds that can be set. If it crosses the sensors, which if it crosses certain limits, then thresholds will be set, an SMS will be sent, an email alert will be sent on the dashboard to the authority for them to take a necessary action. So this just gives a brief introduction to our pollution system. We have mentioned just 3 pollution sensors, but we have also other pollution monitoring, sensors stationed with other pollution monitoring, pollution sensors. All right.